Hi, in this tutorial I'm going to discuss some of the model options available in Fruits. So let's start by opening a Windows of Fruits 2.0. And in Fruits actually you could immediately start entering data, but typically you will want to define the model options so that you can define a Fruits model instance which is suited to your particular problem. Now in this tutorial I'm just going to discuss these model parameters, weighted model, offsets and concentrations. And in a separate tutorial I will discuss the remaining options. But just to remind you quickly that you have this option here, labels, and it defines the form of labeling that Fruits will adopt. It can be either generic or food, and food is oriented towards diet reconstruction studies. In generic, one would talk about things like targets and sources, whereas in food one would talk about consumers and food groups. The model works exactly the same way, it's just really the terminology that changes. So I'll stick to the generic terminology for this tutorial. So let's talk then about these three model parameters. So you can define whether the model is weighted model or non-weighted model, if it's offset dependent or independent, and if it's concentration dependent or independent. In order to know whether these parameters should be selected or not, we need to understand a little bit more about these concepts. And for that I have a PowerPoint to illustrate these points. So let's imagine the following. Let's imagine that you have a target, okay, and you have three sources, source 1, source 2, source 3. Now let's imagine that in your target you measure two proxies. For example, in this target there is one amino acid, let's call it amino acid 1, and you measure for this amino acid 1 the isotopic ratios for carbon and for nitrogen, delta C13 and delta N15. Okay, this is just an example. It could be other proxies, other isotopes, other fractions. It doesn't really matter. It's just to illustrate the meaning of the different Fruits model parameters. Okay. So as I said, you have your target, and you have one amino acid 1, and for this amino acid you measure your delta C13 and your delta N15. So you have these two proxies. Okay. Now, in your three different sources, you'll have the same type of amino acid 1, present in different amounts in each source, and you will also have the data concerning the isotopic ratios of carbon and nitrogen measured in this amino acid for each source. Okay? Now, let's imagine that the question is how much was the contribution of each amino acid in each source towards the target. We are not really interested in the concentration of each amino acid in each source, because we just want to know what was the contribution from the amino acid itself. So this will be a concentration independent model. Okay? Now let's assume that between the isotopic proxy measured in the target, so your delta C13 amino acid 1 and delta N15 amino acid 1, that there is no isotopic fractionation, so it would give you the same signal as the source. In this case, this is an offset independent model. Finally, let's assume that this amino acid in your source fully determines the signal in your target. So your target delta C13 amino acid 1 will be 100% determined from your source amino acid 1, and the same thing applies to your nitrogen N15, the delta N15 amino acid 1. It will be 100% determined from source A1. This is a non-weighted model. And in Fruits, the way to define this would be, let's go back to model options, by removing all of these ticks. Non-weighted, offset independent, concentration independent. Okay? Now let's change this here. So it's the same problem as before, the same question, the contribution of each amino acid, but now there's isotopic fractionation occurring for each target isotopic proxy relative to the source. And I put here random numbers. Let's say that the target delta C13 versus the source, there would be an isotopic fractionation offset of 5 per mil, and for N15 of 4 per mil. Okay? This is just to illustrate, it doesn't really matter. In this case, your model would become offset dependent. Okay? And in fruits, you would have to select offsets. Okay, let's continue. Now, let's imagine that your question changed. You no longer are interested in knowing how much contribution was coming from the amino acid in each source, but you want to know the contributions from the sources themselves. But the sources had different amounts of amino acids. And so you have to use a concentration dependent model. Okay? And in fruits this is done by selecting concentrations here. Okay? So let's move forward to the next slide. Now let's imagine that your target delta C13 signal in amino acid 1 is no longer determined 100% by your amino acid 1. That there is a second amino acid in the source, okay, in each source, and this second amino acid also contributes to the carbon signal of your target delta C13. This could happen, for instance, if you have some kind of biochemical pathway and you have more than one fraction contributing to this target isotopic value. Let's say, for the sake of argument, that 90% of the signal was still determined from amino acid 1, but 10% was from this second amino acid. And this is for your carbon signal. And let's imagine, and this could happen, that your nitrogen signal was still 100% determined from your amino acid 1. Okay? In this case, it would become a weighted model. And the way to define this in fruits is by selecting this option here. Now, in other videos, I will discuss the remaining parameters, and I will give examples on how to how to introduce the values for these different types of model instances. But for now, that is it.